Happy Thursday, everybody. I'm Tyler, and I'm here at Vortic Watch Company to talk about the Victory Watch. It is our newest watch. It's a little bit smaller than any of the other watches we've ever produced, coming in at 43 millimeters.
Shocked. We're all shocked.
Really, what I'm trying to do today is just talk about some of the new stuff we did with this watch and just what makes it different than the other watches that we've produced so far. So the first thing I wanted to talk about is just why did we make this watch? Why is it called the Victory Watch? If you haven't been following along, we got in a 5-year legal battle with the Swatch Group, who owns Hamilton. And this battle was over whether or not we were allowed to use Hamilton pocket watches in wristwatch conversions. During the legal battle, we had our eyes on these specific Hamilton movements for quite some time. They are a 10 size Detent movement, so a little bit smaller than your average 12 size pocket watch and a little bit more modern. These were made more in the 30s and 40s instead of the very early 1900s like most of our watches. And we had our eye on these movements for quite some time. We were actually collecting them, kind of waiting for this case to be over so that we could actually use them in a wristwatch. So after we officially won the case and they appealed as many times as they did, at this point, we are totally free and clear, and it is legal for us to build watches using antique Hamilton movements. It became time to build the Victory Watch. And something else that's neat about the Victory Watch is it's the first watch we've actually machined on our new 5-axis mill. So that's a DMU 50 from DMG Mori. It's a new class of machine, and what 5-axis means is that instead of just the table being able to move kind of left and right, now the whole table can swivel and spin, so you have access to every single side of the part, which is a new machine for us. The next thing I want to talk about is really the difference between detent and pendant-set movements. Most pocket watches that we use, at least, are pendant-set. And what that means is the way to take the crown from set to wind, the actual click, the thing that holds the crown and the stem in that position is different. On a detent watch, like these Hamilton 917, 921, and 923 movements, that whole system is actually located inside the movement. So this will click from wind, like it is now, to set. All that can happen outside of the case. On what I'd call a normal pocket watch movement, a watch that is pendant set, the click was actually located inside the pocket watch case, and that's one of the biggest challenges about making the pocket watch conversions the way that we do. We've created a modern version of that pendant system that I have kind of laid out here, and what that is, it consists of a crown, a stem, a sleeve, and a case tube. So this stem has a raised portion called the boss. And as that boss slips in and out of this sleeve, almost like a little collet, that is what actually creates the click and holds the stem in place to either set or wind a normal pocket watch. And as you can see, there's 4 different parts. It's difficult to get everything to line up perfectly. It's difficult to make everything waterproof. It's difficult to get the correct feel in terms of the weight of the click. These are all things that take a lot of time and energy getting just right for a normal pocket watch. Something that's very attractive about these 10-size Hamilton movements, besides the fact that they're a little bit smaller, is that they're detent. And the way that you use a detent is simply one screw located on the back. So if I give that screw a little turn, now the stem comes right out of the watch. Something else that we really love about these movements is almost all of them have these really neat gold applied numeral dials. We are leaving the original dial on the watch, just like we do with our normal pocket watch conversions. And these dials are just very stunning on every single watch. But to the actual case itself, there's a few things we did differently on this watch because we're now using a 5-axis machine. This is an example. This is actually an old military edition prototype out of bronze. And this case was made on our 3-axis machine, which makes almost all of our watch cases today. And what happens is we machine the watch from the top. So it looks kind of like this when it's finished the first operation. But then in order to do the lug holes, the case tube, and lug holes on the other side, it has to go in through a series of 5 different operations. So it gets machined from the top, and then on one side, and then case tube, and then the other side, all on the same machine, but each time a human has to take it out of a fixture and put it in another fixture. And then finally, the back gets finished on a collet like this. So that's kind of our basic procedure for a normal watch. On the 5-axis machine now, we can take this case while it's on the machine and rotate the whole machine to be able to access the lugs and access the case tube. So it's a really new set of capabilities and a new way to think about the strategy of machining. It opens a lot of new doors. So speaking of strategy of machining, we can talk quickly about, what our prototyping process is. Sky Bartels is our engineer here at Vortic, and he does most of our design work at this point. So him and I work together on the design. He executes the design work, and then generally is migrating that design, that solid model, to me to then program the machines and make the actual parts for our watch case parts. So in the design process, we wanted to do a few things differently because we have new capabilities and we wanted to use them and to make a watch that looks a little different than anything we've ever made before. So the first thing you'll notice with this watch is there's more angles, less curves. We wanted it to look a little bit more industrial and kind of lower profile and understated and not so curvy like our general watches are. Something cool that Sky also added to the design is the angle on the tip of the lugs are actually the gable on the Supreme Courthouse in Washington, D.C. It's the same angle. So that's something pretty neat. So going through that design process, we wanted it to be smaller. So we pushed the limits of the thinness of the walls on the case. We wanted to use some of the 5-axis capabilities. And one of the biggest things that's different about this watch is instead of having all 4 of these parts plus a case, so 5 parts total, this watch has the case tube machined right into the case because we were able to turn the machine over and machine things from this angle. And that simplifies all of this significantly. The other thing is we were using a detent movement. So we machined the actual stem and the crown together in one single piece. We've just simplified the system an incredible amount. One of the other things that's different about this watch compared to our normal watches is we decided to use spring bars in order to keep the lugs very low profile. Normally we use what we call band bars to hold on the straps of our watches. We make fairly large watches and want to make sure that they're securely attached. So that's why we use a threaded screw and a bar to attach the straps on our, again, normal watches. But the Victory watch is a little bit smaller, and you need to make the lugs wider to accommodate that screw and bar system. So in order to keep the watch really clean looking, we wanted to keep it so that there was no marks on the outside of the case and this side profile was really, really clean. And normally we wouldn't be able to do this, but because we are on a 5-axis machine, we can turn the case over at a specific angle and come in with a drill and actually drill it from the inside without hitting the rest of the case. And one of the other things that we've done, and I've talked about this in some of our other videos, is when we started building watches, we used an insert system, precise Delrin machined parts to fit each particular movement. I'm kind of talking about this part here. We went away from this insert system for a little while, and that's what this case is. So this case does not have an insert in it and is just machined to fit a particular movement. But what we found is antique watches aren't perfect. And in order to get the most perfect finished product, we need to allow our watchmakers to have a little bit of fit and finish and be able to modify parts slightly to make everything perfectly snug. On this watch, we actually added an insert back in. We just highly simplified the system. So on this watch, to build it, you put the insert in the case, And that insert is specific to this movement. And then the movement goes right on top. And then the case screws actually tighten right against the case. You can see them right there. And then you insert your crown from the outside of the watch. This is a 3-piece case, so it also has a bezel and a case back. But when it comes to the actual machining, once we've got our design finalized, we've all decided that this is what we want to move forward with. So we've got a 3D model on the computer. The next step is programming the machine. This is all done in Fusion 360 for us, and going from a 3-axis to a 5-axis, we've taken a 5-operation part and turned it into a 2-operation part. It was a very good opportunity to explore some new 5-axis toolpaths and machining strategies, because this is just a totally different animal. Both of these cases started as a piece of stainless steel. This is 316 stainless steel like this. And this goes into a vise in the machine. This 5-axis machine that we have specifically has 60 different tool holders and can choose between a variety of different tools: larger, smaller, longer, shorter, different profiles, chamfering, angles, drilling. This is an example of an end mill. This is kind of the most common tool that we use when we're milling. And what this does is this tool is in a tool holder, and to get rid of material, this tool spins and kind of shaves away material. So our first step is just a puck of stainless, and after we've shaved away material, this is the end result of our first operation. Like I said, this case will get 2 operations. So the first operation is everything from the top. So it's finishing these lugs, it's milling the case tube, it's drilling the lugs, it's doing all of the what I'd call difficult things on this first operation. And that's important because that means we haven't lifted the case up and had any human intervention to change the position of it. So everything will line up perfectly. It's really important with watches and with machining in general, is just if the part hasn't moved, you know it's exactly where it's supposed to be. After that first operation, the next thing we do, we use a 0-point system in the machine for holding our fixturing. So that vise is in the machine for the first op. We simply turn a screw, we can pull that vise straight out of the machine, and then we put in our collets. And this is how we hold the watch for the second operation. We custom make this whole collet system. We buy a piece of steel and machine this. We buy these studs, and this whole thing goes into a 5th-axis rock lock system. And then we buy these collets from Mighty Bite. They're steel collets that then we machine to be exactly what we need them for each part. So this is a collet that has a pin for this female pin slot, and that will locate the rotation, and then a small cutout for this case tube system here. So we'll just spin this case over, put it on there, and then we use a torque wrench to tighten this. And this is how we hold the case for the second operation. So that will remove this hat of material and finish the back of the watch case. So after that part's done, it will look a little like that. So it'll turn that into that. And like I said, this is just a 2-operation part. The bezel, case back, and case are all 2 operations. So they each have a unique version of this collet to hold them for the second operation. But yeah, after that machining is done, we sandblast the case. So it goes through a sandblasting process to get this texture on the outside. And then all that's left is to put the watch together. Here we have a finished watch. And this watch just came off of the watch testers in the assembly room, actually. This is one of the very first finished Victory watches. As you'll see, it has a domed crystal on it. That's a cool feature that we added. And this watch hasn't been laser engraved yet, but it'll get some laser engraving on this case back. And something else you'll notice is the back of the lugs have some cool engraving on them. We added the Scales of Justice, USA, our logo, and the word victory on the back of the lugs, because this watch is really what we think the result of a just process that ultimately allowed us to build this watch in the first place, and it's really cool that it's here now. Well, thanks for watching, everybody. I hope you learned a little bit more about our Victory Watch and how we build watches. It's tough to kind of give a full explanation of everything that goes into building a watch in one episode. So if you have any questions, please leave a comment. I would be happy to answer those. And by the time this episode comes out, these watches should be for sale. And the way that you sign up to be notified for when these watches go up for sale is by going to vorticwatches.com/victory. There we have a wait list, and everybody on that list will get notified every time a Victory watch is finished and for sale. So for today, thanks for watching. I'm Tyler for Vortic Watch Company, and have a great day.